All right, new chapter. 4.1 Inequality Notation. Let's break that down. Inequality. Equality means two things are equal. Inequality means two things are not equal. Notation is the way we write stuff. Note, N-O-T, like note taking, like writing down. So at the bottom of page 126, we see our little table there. You can study that yourself, take some time, look at it. But basically it just shows other symbols besides equal sign. So if we have two numbers, if we have 6 and 6, we can say 6 is equal to 6. This is an equality symbol. But we can have other relationships besides two things being equal. We can have 6 and 7. 6 is less than 7. That's what this means. Less than. Put your English to it. Less than. Equal to. All these new symbols are just mean something else in English. Or we can have something like, what do we do here? We point our little doohickey the other way. Greater than. So these new phrases give us greater than, give us relationships between two numbers. Equal to, this is an equality. Less than, inequality, because these two things are not equal. Or greater than. So to read this left to right, 6 is less than 7. 6 is greater than 5. It's just English, written in math terms. Now, there are other situations as well. 3 others. We can say that 6 is not equal to 7. Not equal to. We can say that a number is 6 is less than or equal to 6. This splits our less than into less than or equal to. And what do you think happens over here? You guessed it. Spell it out so you have time to think about it. See how we have a little line for the equal? It's like the bottom half of an equal sign. So we got our less than on top, our equal to on the bottom. Less than or equal to. Or we can have a third or a sixth type. 6 is greater than or equal to 5. And using these in this case doesn't make much sense, but they'll make more sense later. So greater than or equal to. Anyway, so these are our new symbols, and they mean, remember what they mean in English. Go ahead and write the symbol with its English translation in your notes. Symbol with English translation in your notes. So just like is most of the case in math, it's usually helpful to graph things or put things in pictures so that we understand the concepts better. So if I give you, well, please hold. We're not quite there yet. So as is the case in algebra, sometimes if we have, so let's take 6 equals 6 for example, we don't always know all the numbers we're working with. When we don't know what a number is, what do we use? We use a variable. So if we don't know if we don't know the value of that number, we can just put x. Now if we write this in a sentence, what does it say? 6 is equal to x. So we know automatically that x is equal to 6. No problem there. But if I have 6 is less than x, what is x equal? And another better way of asking it is in terms of the variable. X is greater than 6. What's x? It could be 7, it could be 8, it could be 100, it could be 1,000. We don't know what x is. So sometimes in math, there's not always one exact right answer. Sometimes there's a whole range of values it could be. Now, let's see what this looks like when we graph it. So if we have 6 is less than x, or like I said, another way of saying it is x is greater than 6. And if we write x is greater than 6, these two sentences mean the exact same thing. See, we flipped our x and our 6, but we also flipped the sign as well. So that's very important. Okay, so if we have x is greater than 6. So we want to start with the number they already gave us. So we have a 6. So let's find our 6. Our 6 is right here. But it's not going to equal 6. So we're just going to put a circle over top of it. The circle means it doesn't equal 6. Now, if x is greater than 6, Is it going to be all the values on this side of the circle, or could it be any of the values on this side of the circle? It's going to be this side, because it could be 7, it could be 8, it could be 9, it could be 10, or it could keep going and going forever, which is what that arrow means. So we start at 6, and we draw a line with an arrow, tell us that x is greater than 6, meaning x could be any of these values greater than 6 right here. Let's take a look at another. Let's say x is greater than -7. So let's graph it. Same thing. First, we start with what we know, -7. Can it equal -7? No, it has to be greater than -7. All right, so we start with our circle. And now, is x going to be greater or less than -7? It's going to be greater, so it's going to go to the right. Okay, let's take a look at some others. What if we had x is greater than or equal to 6? Now, the only difference, we still find 6 and circle it, but now because it could equal 6, we fill it in. So we use a solid circle, and it's still going to be greater than. What if we had x is less than 2? Well, find our 2 and go less than it. X is less than or equal to 2. Now it could be 2, so we do the same exact thing, but now we fill in our circle here. What if we have x less than -8, or another way of writing that? Let's get used to finding both ways of writing it. Flip the numbers, so we have -x or -8x, and then flip the sign. So instead of facing to the right, it's facing to the left. -8 is greater than x, or x is less than -8. So find the -8, and then go to the left because it's less than. Great. So let me do a summary page for you real quick. And I don't know how helpful this is, but it tells you that if x is greater than or equal to, you fill in the hole, you go upward, and you can figure out the rest from there. I just made up this graph just now. May not be helpful. Anyway, moving on. Let's go ahead and do our examples from page 128, 4.1b. It gives us an inequality. So we got 2x plus 3 is greater than or equal to 7, and it wants to know if these numbers are solutions. So it asks, are any of these numbers solutions to this inequality here? And so remember, a solution means that it makes the statement true if we substitute it. So let's start with this one, x equals -2. So replace x with -2, and we can solve. -2 times 2 is -4 plus 3. Greater than or equal to 7. -4 plus 3 is -1, greater than or equal to 7. Is -1 greater than or equal to 7? No. Therefore, -2 is not a solution. Let's try another. How about 2? Let's substitute. 2 plus 3 greater than or equal to 7. 2 times 2 is 4 plus 3. Greater than or equal to 7. 4 plus 3 is 7, greater than or equal to 7. Is 7 greater than or equal to 7? Yes. Yes, it is. Therefore, 2 is a solution. I'll leave you with the others for more practice. So basically all we were doing there, taking a value, substituting. If it makes the statement true, it's a solution. If not, it's not. At the top of page 129, we see another table explaining some of the common phrases we might hear. Fewer than, at most, at least, more than, under, no more, no less than, over, above, below. Write that table down in your notes. It's very important to know the English uses of our math terms. All right, so let's take a look at 4.1f. A, we want to turn these English sentences into math sentences. The sum of a number and 3 is at least 7. So sum means we're adding. The sum of what? The sum of a number. We don't know what that number is, so we'll put x of a number and 3. So the sum of a number and 3 is at least 7. What does at least mean? Does it mean greater than, less than, greater than or equal to, less than or equal to? Any of the 6 symbols we already wrote. At least means it could be equal to 7, but it could also be more. So greater than or equal to 7. So that's how we turn that English sentence into a math sentence. The number of cars at the dealership is fewer than 75. What do we got here? Fewer than 75. We know that that's probably going to be less than 75, but what's less than 75? The number of cars. The cars at the dealership is less than 75. Boom. Turn that English sentence into a math sentence. All right. 2 less than 3 times a number is no more than 13. So just like all our other word problems, whenever we see that is, that signals to us that we're going to be using one of our inequality symbols. So one of these 6. Whenever we see an is, we're going to throw one of those in. The key is to just know which one we're using. So 2 less than 3 times a number. So 3 times a number, we don't know what that number is, and 2 less than that. 2 less than 3 times a number is, so we're going to use one of our symbols, is no more than 13. So if it's not more than, it could be 13, but it could also be less. So less than or equal to 13. Boom. We're just turning these English sentences into math sentences. That's all for this lesson. Table B is very important. Just take it slow. Think about it. Think about what each of our symbols mean and how to graph it. But you should get the hang of it pretty soon.